Welcome to episode 12 of Get the Stuck Out, the podcast where we explore what is keeping our brains and bodies stuck and how to reverse this process. For those who have been following my work for any amount of time, you know that I'm all about exploring what is happening in our bodies at the level of our psychology and our biology, and then how to integrate the best of what is currently understood around these topics to help people improve their quality of life. I'm really excited for this episode because it's one I've been thinking about for a long time, but only recently had the time to settle in, go into the research, and pull out what I believe are the most important tools that I can share with you today. If you're even remotely interested in neuroscience, I think there's going to be a ton of interesting information in here for you today. But before we jump in, brief reminder, if you like my material, please subscribe, please review, please share this. My hope is just to get good information out to the most people possible, and so if you're able to help get this information into other people's hands, I really do appreciate it. General disclaimer, the following is not intended as a replacement for medical advice or medical care from your provider, and you should always consult with a healthcare provider before starting any new major healthcare plan changes. Okay, with that out of the way, let's go ahead and get the stuck out. One of the themes that I've spoken about at length is the current research around depression. For the most part, this has been an overview, discussions about where I go into these various hypotheses about what might be driving depression within the brain, within the body. We've touched on inflammation, or the cytokine hypothesis of depression. We've touched on hormones. We've talked about neuron level changes. And in today's episode, we're going to go really deep into the connection between neuroplasticity, which is basically the brain's ability to rewire itself as a result of what's happening in the world, and depression. We're going to explore current research suggesting how certain receptors and neurotransmitters may influence our ability to reshape our brains, basically to engage neuroplasticity, and what might be going on in depression as it relates to neuroplasticity. We'll talk about new research suggesting that we may be able to change our level of neuroplasticity through lifestyle as well as pharmaceutical interventions. And we'll also speak about how psychedelic compounds like psilocybin and ketamine may positively influence mood by way of neuroplasticity. Hopefully, you'll come away from this episode with a renewed curiosity about this fascinating organ that is the brain, as well as some actionable steps towards helping to get the stuck out. Let's start our conversation with a couple of key ideas. The first is the concept that the brain is always perpetually in flux. It is constantly changing the way it's wired. For context, we start out of our lives when we're born at around 100 billion neurons, and each of those neurons has thousands of connections between that neuron and other neurons. These are called synapses. Over the first decade of life, a child's brain forms trillions of new synapses, where you have these branch-like tips from one neuron that connect to the back end of the next neuron. In fact, it is thought that we have actually 15,000 synapses per neuron by the time we hit age 2 to 3. In the first year of life, the brain doubles in size, and by age 5, it is nearly 90% the size of an adult brain. These early years with such changes in neuroplasticity and brain structure are a time of incredible neuroplasticity. As our neurons are modifying their structure and connections at such a high rate, there is a lot of opportunity here, but there's also a lot of vulnerability. It's generally thought that after childhood, as we enter puberty and adolescence, our brains begin a process of rapidly refining their connection network. The technical term for this refining is called pruning, which is when the brain eliminates unused or excessive synapses between neurons, and this is especially relevant in a part of the brain called the cerebral cortex. According to research published in the Proceedings of the National Academy of Sciences, this process of pruning is thought to occur throughout adolescence and may in fact continue into the third decade of life when things level off a bit. And I want to be clear, pruning is always happening, but the rapid pruning process, that's what we're talking about here, seems to be more concentrated in early life. The parallel here between our psychological frameworks, our patterns of behavior, and our brain is incredibly obvious. As things get a little bit less plastic in our brain, we also become a little bit less plastic in our approach to the world. It's also important to note a key fact here. Neuroplasticity occurs throughout the lifespan. You are changing your brain at this very moment. And in fact, your brain today, just as it was yesterday, very different from the day before. So the brain you have right now is physically and functionally different from the brain you had yesterday, just as it will be physically and functionally different from the brain you have tomorrow. How do we know that this neuroplasticity is occurring throughout our lifespans? Well, one reason is the idea of memories. While scientists haven't necessarily said this is exactly how memories are stored, the synaptic changes or neuroplastic changes are actually one of the leading hypotheses for how memory exists. Scientists have called this the synaptic plasticity and memory hypothesis. Another piece of important evidence comes from looking at brains through scans, so MRI and CT scans. This is where researchers are able to link external events like childhood stress with structural changes in our brains. The bottom line to all of this is that our brains are continually changing as a reflection of what comes in through our bodies. And importantly, this can be for the better or for the worse. Let's shift now and talk about depression. Depression is one of the leading causes of disability around the world, and unfortunately, even in the best cases, even with the best care, remission rates of depression are relatively low, and relapse rates are relatively high. Now, I've spoken about depression many times on my podcast and in other areas. And before I start connecting the dots here between depression and neuroplasticity, I just want to say if you are struggling with depression, please seek professional assistance. While I like to talk about the role of lifestyle modification and depressive symptoms, I really don't think these are the interventions you want to be pursuing first line if you need help now. So this is why seeing a mental health professional and getting evaluated by a mental health professional is so important. When I think about depression, I think about the psychological manifestations of biological mechanisms. By this, I mean, I think about how the experience of depression, which we would describe and feel as low mood, as a lack of interest in things, decreased appetite, that these are the psychological manifestations of what is happening at a biological level within the body and within the brain, which is really driving that psychological experience. One of the things that is really notable about many mental health conditions is that the way a person sees the world in these conditions tends to be a bit distorted compared to how other people might see the world. And of course, you could say if that's obvious, a person with anxiety sees the world through a more anxious lens, and a person with depression sees the world through a more depressed lens. But there's more to this story than just that. When researchers look at depression, look at people with depression, and look at how they see the world and make choices, they actually notice a couple of key themes. One, not unexpectedly, is that in depression, people appear to have a decreased sensitivity to pleasure, and they have an increased sensitivity to negative things. But there's more to this. So people with perfectionism have been shown to have higher rates of depression. People who have less rigid coping strategies also have lower rates of depression. And in one widely cited study, published back in Psychiatry Research in 2010, it was shown that people with depression have more trouble with task switching, with changing their cognitive focus from one thing to another, or updating the way that they see the world. Since then, further research has actually shown that depressive symptoms are associated with a decreased ability to update interpretations. The point here is that from a psychological perspective, there's a lot of evidence for stuckness in thinking in depression. Or put another way, there is a decrease in psychological and cognitive plasticity. In fact, researchers have actually characterized depression as a disorder of decreased or disabled cognitive flexibility. When we then go to our neuroanatomy to ask what might be underlying some of these observations, we could really go to any of the hypotheses that I previously discussed as tethered to depression, everything from neurotransmitters like serotonin to changes in the immune system and inflammation. But I think it's especially notable here to make the connection between more rigid thinking patterns and decreases in brain plasticity, neuroplasticity, because there are just so many obvious parallels. And it actually turns out that depression has been linked to deficits in neuroplasticity. So let's jump to that research. If you were to take a large cohort of people, a large group of people with depression, and then a large group of people without depression, and you put them into brain imaging scanners, so a CT scanner, an MRI scanner, some of the more likely findings you would see in the depressed group relative to the non-depressed group is that they would have decreases in brain volume, which we would call atrophy, in a part of the brain called the prefrontal cortex, which is involved in higher order thinking, emotional regulation, as well as a part of the brain called the hippocampus, which we commonly think about as playing a big role in our memory. If you had access to a functional MRI scanner, if you're in a fancy institution, you would be able to see that there are changes in depression with connectivity. Basically, activation patterns in the brain as far as how they connect are different in people with depression compared to healthy controls. And so what you see then is that there are structural as well as functional changes that are observable in people with depression compared to people who do not have depression. These changes have been said to reflect deficits or problems with neuroplasticity in the brains of people with depression. And this may be the biological correlate to the psychological manifestations that appear to be kind of a loss of plasticity. One thing that is important when we consider these types of results is that sometimes we see changes in brain structure, again, things like atrophy, and we think that this represents the death of neurons. And it makes sense. You look at a brain, you see that there is less mass, you think, well, there must be less neurons. Sometimes that may be the case, but what researchers have really talked about more as it relates to these findings in depression is that we're not necessarily seeing the death of neurons in the prefrontal cortex and the hippocampus. Instead, we are seeing changes at the level of the synapse, which, remember, that is the connection between neurons. So when you take brains of people who died who had depression and you look under the microscope, researchers have shown that there is not necessarily a decrease in the number of neurons, but a decrease in the size of neurons. And that actually may be good news, because what we may be seeing here in these brain scans is a deficit in neuroplasticity, which is something that we can change. It isn't that we can't change the growth of new neurons. This is a process called neurogenesis, but it seems like on the whole, we don't really grow all that many new neurons as adults, but we do make major changes to the way that those neurons are structured and the way that they connect to other neurons. There's other data too that suggests that neuroplasticity may be impaired in depression, and this is perhaps a little bit more indirect. These data relate to an important protein called BDNF, or brain-derived neurotrophic factor. BDNF is thought to be a key molecule involved in neuroplasticity. It actually may be one of the strongest signals for a neuron to form new or stronger connections with other neurons. It turns out levels of BDNF tend to be a bit lower in people with depression, and in animal models, when you get rid of BDNF production, it actually correlates with the animal version of depression. In fact, levels of this protein, BDNF, have been found to correlate directly with neuron structures that are involved. We're going to go one level deeper on this podcast, and I promise this will be the most technical information that I provide. The science, however, is necessary because it is going to help you, I believe, to understand why certain molecules, including psychedelics, may be helpful in treating depression. Here's the science. The strength of two neurons, as far as their connection, is thought to be a function of a couple of receptors for a neurotransmitter called glutamate. This neurotransmitter glutamate is the most abundant excitatory neurotransmitter in the brain. So it's really important as far as communicating information from one part of a brain to another one. So you have these receptors for glutamate that live in the synapse, and activation of these receptors may actually tell a neuron whether it needs to strengthen its connection to another neuron or whether to weaken the connection to another neuron. And both of those things are actually examples of neuroplasticity, because again, neuroplasticity is just how the brain changes its wiring, changes its structure as a result of the input coming in. So to reiterate here, in the synapse, in the connection between neurons, there are these receptors for a neurotransmitter called the glutamate, and the activation or deactivation of these receptors appears to be a main mechanism of neuroplasticity. Issues with these receptors have been implicated in depression. Okay, take a breath. Let's move on to how can we increase healthy neuroplasticity and how that relates to therapeutics for depression. As you may already know, the most commonly prescribed drugs for depression are drugs that target molecules like serotonin, norepinephrine, and dopamine. These drugs go by names like SSRIs, SNRIs, TCAs, and MAOIs. For some time, it was thought that the central issue in depression was a deficit, not having enough of a specific molecule. In this case, the big one is serotonin. So all we had to do to lift the veil of depression was simply to give drugs that increased levels of serotonin. Now, in the past couple of decades, researchers have become far more critical of this hypothesis, and this hypothesis is known as the monoamine or serotonin hypothesis. There are a number of reasons why people are questioning this as kind of the central dogma describing what happens in depression, and I'll go into this in further podcasts, but the bottom line here is that there's more to the story. As it was later discovered, these antidepressive medications that we thought worked only on serotonin and these other molecules may actually work in part by augmenting, by boosting neuroplasticity in the prefrontal cortex and the hippocampus, which again, these are the parts of the brain in which impaired neuroplasticity is implicated in depression. The way that this works may in fact be by increasing levels of that protein, BDNF. There was actually a mouse study where they showed that when they blocked BDNF production, it blocked the behavioral effect of antidepressants. And what's really interesting is it turns out that some psychedelic molecules may work on this exact same pathway. So, to take a step back here, if you've been following any of the research on psychedelics over the last couple of decades, you probably know that these molecules have shown a lot of promise in certain mental health conditions. And these range from PTSD to addiction to depression. And in fact, there's active research right now that is looking at the effectiveness of these molecules on depression, and prior research that indicates a pretty large positive effect on depression for people who have tough to treat and end-of-life depression. You can expect a whole lot more from me on this research. It's something that I personally find absolutely fascinating, but suffice it to say that so far it has been pretty impressive. In addition to finding out how to use these molecules to treat diseases, scientists have also been looking at how these molecules work. How do they exert their effects on the body and on the brain? One of the pathways that is increasingly getting press is, you guessed it, neuroplasticity. Of all of the psychedelic molecules out there, ketamine is the most relevant to this story. Ketamine is a molecule that was initially used only for anesthesia during medical procedures, but along the way it was found that ketamine had a powerful positive effect when it was used on certain people with depression. In the United States, ketamine is now being used for treatment-resistant depression in clinics around the country. One of the things that makes ketamine so interesting as a therapeutic for depression is it has an incredibly fast onset of action. Conventional antidepressants, your SSRIs, SNRIs, they might take 4 to 6 weeks before people have a noticeable effect. But with ketamine, you can have an appreciable decrease in depressive symptoms within hours. So it's led scientists to ask, how is this possible? One of the best explanations that they have come up with is that ketamine appears to directly act on neuroplasticity mechanisms. It leads to rapid changes at the level of the synapse, and these effects may lead to the fact that people feel rapidly better right after taking this medication, a sensation that can actually last for 7 to 10 days after a single dose. So in animal research, they have found that the changes in behavior that occur after ketamine correlate tightly with changes in proteins and functions of the parts of a neuron that are involved in neuroplasticity. And remember that kind of technical bit I told you about the glutamate receptors? It seems like ketamine acts on these glutamate receptors in the synapse. Though they haven't been studied in as much detail, other psychedelics may positively influence neuroplasticity as well. Unlike ketamine, classical psychedelics like LSD and psilocybin appear to act primarily on a serotonin receptor called the 2A receptor. However, we now know that these receptors are located all over the body and can influence a number of systems that influence neuroplasticity. Additionally, there's more direct research that shows that psychedelics may positively augment markers of neuroplasticity. One study looked at people taking ayahuasca, which is a South American psychoactive brew, and it found that when people took this molecule, when they took this plant medicine, that there were changes in plasticity promoting proteins, specifically BDNF. So BDNF levels were elevated in people who took this ayahuasca. Additionally, it's been found that very small doses or microdoses of the molecule LSD may increase levels of BDNF in humans as well. Lastly, several studies have linked the fungal psychedelic called psilocybin with neuroplasticity. In fact, there was a paper that just came out in the journal Neuron in 2021 that showed that one dose of psilocybin induced structural remodeling in the brain within 24 hours that lasted a month, and specifically these were changes in neurons in the prefrontal cortex. This was a study that was conducted in mice. All right, we have covered a lot of science here, and we've covered a wide variety of concepts around neuroplasticity and depression. I do want to make sure we get to some actionables because the goal here is always to understand science in order to improve quality of life. To appreciate potential solutions to the issues with deficits in neuroplasticity, let's start by understanding the problem just a little bit better. We've talked at length about the connection between depression and neuroplasticity, but why might people with depression have impaired neuroplasticity? There are several potential explanations, but I think the most solid invokes the topic of stress. Now, stress, as you've likely heard, is often villainized in conversations around our health. While we need some stress in order to be healthy, it's thought that too much stress for too long can be incredibly damaging to our brains and to our bodies. It's especially thought that when high doses of stress happen earlier in life, the consequences on our brain function may be severe, and they may last for decades. So how does this link to neuroplasticity? As it turns out, stress has been consistently associated with decreases or deficits in neuroplasticity. In animal models, higher stress correlates with neuronal atrophy, reduced synaptic density, and cell loss, as well as depressive symptoms. In fact, atrophy of prefrontal cortex neurons can be seen in animal models in as little as 1 week when the stress is experienced for 20 to 30 minutes per day. In humans, chronic stress correlates with atrophy in the prefrontal cortex and in the hippocampus. And while the mechanism is a little bit technical, it's thought that one of the ways in which the stress pathway damages neuroplasticity is by decreasing expression of our friend, that protein BDNF. Okay, let's move to the final part of today's podcast and describe what we may be able to do to help offset some of the negative impacts on neuroplasticity. Fortunately, there's decent evidence to suggest that we can positively increase neuroplasticity by way of lifestyle interventions, and there are a couple of categories of lifestyle interventions that especially hold promise around this. First and foremost, if you're seeking to improve neuroplasticity, physical activity is key. Multiple studies have shown that physical activity correlates with better brain function as well as better mood, and recent research shows that getting some physical exercise may actually have a protective effect against depression. It's especially notable that exercise appears to lead to changes in the prefrontal cortex and the hippocampus more than in other parts of the brain, which is important because, again, these are the regions of the brain that appear to be most involved in depression. In a series of studies, researchers showed that children as well as elderly people who had higher aerobic fitness had a bigger hippocampus, and there have actually been interventional trials on mental health and neuroplasticity as well. There was a paper published in JAMA Psychiatry in 2010, and it looked at people with schizophrenia, and it had them do 3 months of physical activity, and they found that those who did physical activity had a 12% increase in the size of the hippocampus. So again, representing probable neuroplasticity. Notably, multiple studies have shown that acute bouts of physical exercise appear to increase levels of BDNF. And while there is evidence for both aerobic and anaerobic fitness in increasing levels of BDNF, the majority of these studies seem to indicate that aerobic fitness has a more powerful effect. Next up, moving your brain or making it still to enhance neuroplasticity. We talked about how physical movement can be used to help improve brain function and plasticity, but it also turns out that moving your mind may have some of the same benefits. Cognitive engagement has been related to lower levels of cognitive decline as people age, and it's thought that mental exercises may actually help to create new synapses in the brain. In animal research, it's been found that being in a more stimulating environment, which is sometimes called an enriched environment, correlates with increases in BDNF as well as the actual creation of new neurons, a process again called neurogenesis. What does this mean in practice? Challenging your brain by learning something new, putting yourself in an uncomfortable situation, basically pushing your brain a little bit, may be a solid way to help promote neuroplasticity. Now we can go to the opposite end of the spectrum, or at least what seems to be the opposite end of the spectrum here, and think about how exercises in mindfulness may actually benefit neuroplasticity. So research has shown that when people engage in mindfulness practices, that there appears to be a positive impact on the parts of the brain that are involved in depression, and these changes may be by way of neuroplasticity. In a study called The Neuroscience of Mindfulness Meditation, which was published in Nature Reviews in 2015, researchers looked over a wide variety of studies, and they concluded multiple brain areas appear to be involved in mindfulness and meditation, and those include the prefrontal cortex. In fact, they found evidence for increased activity of the prefrontal cortex as well as increased connectivity between the prefrontal cortex and areas involved in emotional regulation in those who practice mindfulness meditation. The researchers also proposed that some of these changes seen in meditators may be the result of neuroplasticity. Specifically, it seems like mindfulness meditation may help offset the effects of stress on neuroplasticity and BDNF. Diet is also considered one of the biggest variables when it comes to brain health, and there's a good reason for this. Basically, all of the variables that seem to influence brain health, like oxidative stress or inflammation or the health of our blood vessels or our hormones, are affected by the food that we put into our bodies. Healthy diets that emphasize less processed food correlate with better cognition into older age as well as a lower risk for depression. There are a lot of ways in which the connection between food and depression and neuroplasticity can be made, but I want to be clear, there isn't actually all that much human data that directly links neuroplasticity to our food. Instead, we have to look at cellular mechanisms and animal data. This doesn't mean we shouldn't look to diet as a significant tool here, but we need to be cautious of over-extrapolating from limited data. Also, before I want to get to anything specific here, let me remind you again, consult a medical professional before you make any major changes to your health plans, including major changes to your diet, especially if you're considering fasting in any of its forms. Generally speaking, when we think about how to use diet to improve our health, I like to use the three-lever framework from Dr. Peter Attia. As he describes it, there are three major levers of diet that we can restrict. These are the quantity of food, the timing of food intake, and the composition of our food. When it comes to these levers, he says we should shoot to always be pulling at least one, often pull two, and sometimes pull three. If you're interested to learn more about this, he has a great article on this subject on his website, which I'll include in the show notes. And I think we can look at this dietary framework through the lens of depression and neuroplasticity. Let's start with restricting the timing of our eating. Most people in the Western world are eating from sunup to sundown and then some. We're also talking about snacking all day and sometimes all night long. So why is that a problem? It is thought that this inundation of calories throughout the day may actually stunt our body and brain's ability to engage in rest and repair processes, including neuroplasticity. Some fascinating research has shown that during a fasting state, which, by the way, has variable definitions, that there is an increase in the production of various molecules in the body. One of these molecules is a ketone body, which is called beta-hydroxybutyrate. And according to a Nature Review paper published in 2017, periods of fasting or exercise might increase levels of this molecule, beta-hydroxybutyrate, which is produced by the liver, This molecule could then enter the brain and increase the production of BDNF, leading to an increase in neuroplasticity. While there are many different ways to implement time restriction in food that ranges from time restricted eating, where you only eat food for 8 hours of a 24-hour day, or longer fasts, it's worth thinking about how this, especially when you consider the additional benefits to metabolism, immune function, and other systems, may have a positive impact on our mood and our cognition. Let's now turn to another lever, and that is the quality of our food. As you probably know well, modern day food is basically junk. It's highly processed, nutrient stripped excuse for food. Compared to people who eat this standard American style diet, a 2020 review of 20 studies found that people who instead consume a more whole food diet had a lower risk for depression. In fact, there was even a randomized controlled trial back in 2017 showing that people who had depression had a statistically significant improvement in their symptoms when they ate a Mediterranean-style diet that emphasized whole grains, vegetables, nuts, legumes, and omega-3 fats. And as it relates to omega-3 fats, just a quick note here, some of these can be found in plant sources, but they tend to be more concentrated in animal products, especially in fish oils. So these omega-3 fats are notable because they have been found to promote neuroplasticity, including in the hippocampus in animal research. Other food-based molecules to know about as they relate to neuroplasticity include curcumin, which is often consumed in turmeric. Curcumin and turmeric have been found to help block stress-related damage to neuroplasticity in a rat model, and there's also some data around a whole coffee fruit extract, which has been shown to increase levels of the protein BDNF in healthy humans. On the whole, it seems like it may make more sense for people to prioritize a long-term healthy diet, a balanced diet that is rich in whole foods, than it does to try to boost neuroplasticity with a single food or a single supplement. The last idea I'd like to cover as a way of positively modulating neuroplasticity is looking at the power of sleep. Now, there are so many reasons why sleep is an incredible topic in the world of health, and I'll be sure to get into these in future episodes. When it comes to sleep and neuroplasticity, there are several lines of interesting research to consider. First, slow-wave sleep, which you can consider to be deep, non-REM sleep, is directly associated with changes in neuroplasticity. In animal research, gene activation related to neuroplasticity in the cortex and the hippocampus has been found to be under the control of sleep. In fact, sleep may actually represent one of the most important regulators of brain-wide neuroplasticity we have available. Then we layer in the fact that depression and sleep problems are strongly associated, where sleep issues are more likely in people, or sleep issues predict people developing depression, and people with depression are more likely to develop sleep issues. While there is some really interesting research on sleep deprivation therapy in patients with depression, for the most part, it may make more sense to simply focus on getting higher quality sleep for around 7 to 9 hours each night. Strategies to aid this process can include cutting out caffeine intake in the afternoon, winding down before bed, cooling the room you sleep in, removing electronic devices from the bedroom, in addition to just having a more consistent evening wind-down routine. Okay, well, we've covered a whole lot of information in this episode, and I hope you have a better understanding of where neuroplasticity and depression overlap, as well as an idea of how molecules like psychedelics, as well as lifestyle interventions, including diet, exercise, and sleep, can factor into the equation. There's obviously a lot of very technical information in many of these papers I reference in this podcast, and if you're interested to learn more, I'll link to some of these in my show notes, as well as on my website, austinperlmutter.com. As always, my hope with this podcast is to help you better understand stuckness and how you can help yourself and others to get the stuck out of your life. So if this was valuable to you, please leave a review. Share this episode with a friend, or just let me know what you liked or didn't like. Also, please consider subscribing to this podcast. And for more of these topics, you can find me on social media or on my website, austinperlmutter.com. I look forward to speaking with you again soon, and until next time, this is Dr. Austin Perlmutter, wishing you get the stuck out.